2 billion years ago, two enormous galaxies slammed into each other, triggering a massive gravitational pileup that tore their spiral structures apart. Today, the resulting wreckage is known as Centaurus A. Sitting just 11 million light-years away from Earth, it is one of our closest galactic neighbors. Photographs of the galaxy reveal a highly unusual structure, a glowing galactic sphere that appears completely bisected by a massive dark gash. That dark band consists of highly compressed, incredibly thick cosmic dust. This massive dust lane serves as a persistent physical record of the ancient collision, locking the details of the impact into the galaxy's modern structure. The problem for astronomers is that this dust acts as a physical wall, blocking our traditional observational tools. This diagram illustrates how that wall functions. The short wavelength waves of visible light bounce off the dense cluster of dust particles, scattering in all directions instead of passing through. Because of this scattering effect, the exact center of Centaurus A has remained hidden in total darkness for as long as we have studied it. Astronomers know exactly where the collision took place, but they have been locked out from seeing its ongoing physical consequences. To understand the aftermath of the merger, observation must move beyond the limitations of the visible light spectrum. The James Webb Space Telescope was designed to bypass this obstruction by looking at the galaxy in a different light. Webb's NIRCam and MIRI instruments allow the telescope to observe the universe in the infrared spectrum. Returning to our diagram, infrared light behaves differently. These longer wavelength waves effortlessly bypass the dense particles, passing straight through the material that scatters visible light. When Webb directed these sensors at Centaurus A, it uncovered millions of individual stars buried inside the dark lane. Shifting to the infrared spectrum makes the previously opaque barrier appear transparent, revealing an active inner world that visible light could never reach. By looking past those newly visible stars to the exact geometric center of the galaxy, the true engine of this system comes into view. This image reveals an actively feeding supermassive black hole surrounded by a warped, glowing accretion ring of superheated matter. When those two original galaxies merged, the immense gravitational forces shoved massive amounts of fuel directly into the center, effectively turning this black hole on. Today, the gorging black hole launches powerful, highly energetic jets and drives fast-moving ionized gas outward into the surrounding galaxy. The kinetic energy from a 2-billion-year-old collision continues to power the galaxy's central engine right now. Webb's data clearly identified the black hole, but it also returned an unexpected discovery that researchers are still trying to map. Completely surrounding the center of the galaxy is a strange, glowing S-shaped structure that only appears in infrared. Astrophysicists currently cannot fully explain the physical mechanics that created this specific shape. Leading hypotheses suggest it could be a direct shockwave from the ancient merger, a shape sculpted by the outward pressure of the black hole's jets, or a massive nursery of star formation driven by the collision. In astrophysics, resolving one mystery often reveals new structural complexities underneath. We cleared the dust to find the black hole, only to find an entirely new structure we cannot yet explain. When you pull back and view the entire structure of Centaurus A, you see a system defined by its violent history. Billions of years have passed since the initial impact, yet the galaxy remains highly active and incredibly chaotic. Galaxies function as energetic, high-speed engines, shaped by forces that can persist for eons. Cosmic collisions do not end when the galaxies merge. Their stories continue to be written in dust and gravity, proving that in space, some wounds never completely disappear.